Hi student, welcome to Learn Chemistry with Emerald, and in today we are introducing matter. Introduction to matter. First and foremost, um, you know that matter is anything that has mass or occupies space. But before then, also understand that matter have a dual nature. Matter has a dual nature. It could exist as a wave and it could exist as a particle. In chemistry, we study more of the particle nature of matter. So in this course or in this topic today, we are going to be focusing on introduction to the particulate nature of matter. We are going to define matter, look at the properties of matter. We are going to look at discrete particles of matter and etc. So let's go into the course. What is matter? Everything and us begins and starts with a matter, including you, the air you breathe, your body, everything around you, everything that you can see, everything that you can touch, everything that you can see around you, all begins with matter. In fact, the whole universe starts with matter. So matter, therefore, is anything that occupies space and has mass. Anything that occupies space and has mass. For instance, look at some of the things that we highlighted here. The person's weight on Earth is around 560 Newton. His weight changed on the moon to 90 Newton. But his mass is always the same. Now, please take note that the mass of an object is a measure of the amount of matter the object has. The mass of an object is a measure of the amount of matter the object has. It is different from weight. Weight is the mass of an object under gravity. Weight is the mass of an object under gravity. And that is why weight varies based on wherever you find yourself. For instance, if you are on Earth, your weight will vary when you are on the moon or other satellites or planets, as the case may be. But your mass will always remain the same because it is the quantity. Mass is the quantity of matter that you have. Now, the space, because we have said that matter is anything that has mass and occupies space. Therefore, mass is the quantity of matter that you have, or the measure of the amount of matter an object has, and volume, or the measure of the space occupied by an object is volume. So in matter or every person or every object has a mass and a volume, and that is why during our measurement, chemical measurement, we have mentioned that two key fundamental quantities in chemistry and every object has is mass and the volume. Mass is the quantity of matter in the person, and space is the measure of the space the object occupies. So remember this, very, very important. And of course, mass, we have said that mass is also different from weight because mass remains constant and weight changes based on the location that you find yourself. Let's move on. Let's look at classification of matter. Matter can be classified as pure substance and impure substance. And another word for impure substance is mixture. Under pure substance, we have the elements and the compound. Under impure substance, we have the mixture, and the mixture can also be subdivided into homogeneous and heterogeneous. We are going to be talking about pure and impure substance very soon in details. So this is classification of matter. So everything is based on every object can be either be pure rather. Every substance can either be pure or impure. Pure substances have elements and compound as a subcategory. Impure substances, which is mixture, can be homogeneous and heterogeneous. Now let's look at matter more in details. The definition more in detail. Now you have said that matter is anything that occupies space and has mass. Now pure substance are matter having an invariant chemical composition and distinct property. That means that they do not have a variable chemical composition. Their chemical composition are constant and they have distinct properties that make them unique. For mixtures, they are matters that contain two or more pure substances that retain their individual identity and can be separated by physical method. Mixtures are matter consisting of two or more pure substances that retain their individual identities and can be separated by physical methods. Now we have said that pure substances are subdivided into two. We have elements. Elements are defined as fundamental substance that cannot be separated into simpler substance by chemical methods. The elements are fundamental substance that cannot be separated into simpler substance by chemical methods. While compounds while compounds while compounds are substance composed of two or more elements in a fixed proportion. They can be separated into simpler substance and elements only by chemical methods. Only by chemical methods. They can be separated only by chemical methods. Now, for mixtures, we have said mixtures may be homogeneous or heterogeneous. When it is homogeneous, that means that it is a mixture that has a uniform composition and properties throughout. They have a uniform composition and properties throughout. While heterogeneous, their mixtures that are not uniform in composition and properties throughout. They are mixtures that are not uniform in composition and properties throughout. Now let's look at more closely now this classification. We have said that a pure substance has a definite and constant composition like salt or sugar. And we have said that a pure substance can be either elements or a compound and their composition does not vary. Um, an example is oxygen, which is an element that we have mentioned. And when they are isolated, they cannot from mixture, they cannot be further broken down. But, some of them are isolated from mixtures. For instance, most of these elements that exist in combined state, when they are isolated, they cannot be further broken down. Okay, now let's quickly look at properties of pure substances. Number one, it can be separated into two or more substances by physical or mechanical means. It is homogeneous. Its properties are constant throughout the whole sample. Its properties do not depend on how it is prepared or purified. It has a constant chemical composition. Now let's look at definition of mixture or impure substance. Mixtures are physical combination of pure substances that have no definite or constant composition. The composition varies according to how they are being prepared. They can be homogeneous or heterogeneous, as you have said, and they composed of variable portions of molecules and atom. They composed of variable proportion of molecules and atom. Now let's look at their properties. Number one, it can be separated into two or more physical substances by physical or mechanical methods. It displays the properties of pure substances making it up. Mixtures usually have the properties of substance that makes them up, and that's why we say they are the properties that make up a mixture are able to retain their individual properties. The elements or the substances that makes up a mixture are able to retain their individual properties. Number three is that a composition of mixtures varies, not like uh, pure substances that do not vary. Their composition vary by changing the proportion of pure substances making it up. For instance, if you have a mixture like a sand and salt mixture, you can vary the composition. You can increase the composition of sand by adding more sand, or you can increase the composition of salt by adding more salt. So the composition varied based on the proportion of the substances that are making up the mixture. Okay, then heterogeneous substance, they are heterogeneous. Mixtures are heterogeneous in the sense that uh, ones with non-uniform composition throughout samples are always mixtures. They are heterogeneous in this that they contain different substances. Okay, let's look at we have established mixtures and or pure substance and pure substance. Now, matter has different properties. Like we have said, everything around us is made up of tiny particles or pieces. The particles that make up matter are either atoms, molecules, or ions. They are called discrete particles of atoms. Discrete particles of matter. So we have three discrete particles of matter. Like we have said, please underline that all substances are made up of tiny pieces or particles. These tiny pieces or particles are now subdivided into three. They can be atoms, ions, or molecule, and then they have properties like hardness, like color and texture, like malleability, like flexibility, like viscosity, like conductivity. So we talk about these atoms and other ones now. Now, before we go into discrete properties of matter, we look at properties of matter. Properties of matter can be divided into two. We have the chemical property and the physical property. Now, for the chemical properties, they are properties that become evident during a chemical um, reaction. For instance, properties that you see when a matter is undergoing chemical reaction, like the reactivity, is it reactive or inert? Like the flammability, is it flammable, etc. Now, we also have the physical property. Physical property are property that can be measured or observed without changing the chemical composition of the substance. An example of a physical property is the solubility. Does it dissolve in water? The color, etc. Now, physical properties can also be subdivided into two. You have the extensive property and the intensive property. Cannot be used to The extensive property cannot be used to measure cannot be used to identify a substance because it changes. For instance, they are mass and volume. The mass and volume of a substance changes over time, so you cannot use mass and volume to identify that particular substance, because in physical property what you want to do is that you identify and measure a particular substance, and you are able to identify it in fact we call it the intrinsic property, because it distincts the substance from one another. Everybody have their intrinsic property, something that distinguishes us from every other person. For instance, you can have a twin, but and then of course they have a lot of chemical, or they have a lot of chemical properties in place because they are coming from the same womb. However, they are going to have different physical property because the nose of one might be flat while one will be round, and the leg of one might be long while one will be short. Some physical properties will separate them so that you can know that this one is A and this one is B. So that's why sometimes physical properties are called intrinsic property, because they are properties that separates a particular substance from another substance. Then why chemical properties are called extrinsic property, because they are common to a particular group. For instance, each compounds have each related compounds, like we call them like organic compounds, have something in common. All organic compounds have something in common, and most of them are their chemical properties. So something that they have in common, they are called extrinsic property, and they have the chemical property. They are evident during chemical reaction. And like I've said, physical properties is subdivided into two: extensive and intensive. Extensive, you cannot use it to identify a substance because it changes. Why intensive, you can use it to identify a substance because it does not change no matter the amount of present. We have the color, the melting point, the boiling point, etc. Okay, let's move on to another one now. Let's look at what matter is made up of. A lot of people have come up with different proposition of what matter is made up of. Uh, Especially some of these things were researched by the Greek philosophers and Greek chemists or alchemists then. Leucippus, Democritus, a lot of them doubting came up with proposition. For instance, Leucippus and Democritus believed that the nature of matter consists of two things, or nature generally consists of two things: atoms and the void or the space that surround them. They believe that the nature generally um, consists of atoms and the space or void that surrounds them. They believe that atoms are physically but not geometrically indivisible. They are physically but not geometrically indivisible. So the word atom comes from atomos in a Greek word, which means indivisible particle. So Democritus came up with a proposition about atoms. Okay, and he said atoms composed of all matter composed of atoms in void. Then he also said that atoms were indivisible and indestructible. He also proposed that properties of atom, that is his own theory now, properties of atom differ in shape, size, and arrangement, and then the shape of atom determine the substance properties. The shape of atom determine the substance properties, and then he used some things to represent it. For instance, he used fire in terms of the proposition 1 and 2, the theory 1 and 2, fire, and then for proposition 3 he used wine and then clay. So he was using different things to represent his proposition or theory. Now, however, Aristotle was of different opinion, and he said no, he does not agree with Democritus that so Aristotle said all matter is made up of four basic substances. We get to know that one later. Now, over the time, in recent over some other time, another English chemist came up and said, okay, enough of what our old people have said. Now, here is new inventions and new discoveries about atoms. So he come up with what is called the doubting atomic theory. That one gave a breakthrough to the study of atom. However, it has its own limitation. We are going to be studying that under atomic chemistry in a further discussion of this lesson that we're having. So we are going to discuss John Dalton in details. He developed a theory to explain why elements in a compound always join in the same way. That's one of the key highlights of his own proposition. He proposed explanation for many of the known laws describing the behavior of matter. As at that time, a lot of laws have existed, have started coming up, and of course, his theory was able to explain a lot about the law that describe the law. So, but his major work, his major summary, or the major summary of his own theory was that all matter is made up of individual particles called atom, which cannot be divided. So he said matters are all, all all matters are made up of indivisible particle called atom. And then he went on to postulate about 5 theories. However, based on recent discoveries, um, they negate some of his theories. Only one of them um, were accepted, and then his theory was modified. So under atomic structure of atom, we are going to discuss each of them because we are going to be linking them with some of the theories and models of atom that were explained. Okay, and um, like we have said, and I introduced the other time. Now, matter is made up of tiny and discrete particles. These particles can be atom, molecules, or ion. All 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 matter are made up of tiny pieces or particles. So we call them the discrete particles of matter. They are atoms, they are molecules, or ion. What is an atom? An atom is the smallest particle of an element that has all the properties of the element. An atom is the smallest particle of an element that has all the particles of the element. You can also define an atom like this. An atom is the smallest particle of an element which take part in a chemical reaction. An atom is the smallest particle of an element which take part in a chemical reaction. A molecule is a neutral particle that consists of 2 or more atoms which are chemically bonded together. A molecule is a neutral particle that consists of 2 or more atoms which are chemically bonded together. Number 3, ion. Or before we go with that, we can also define a molecule as a substance which is capable of independent existence and still retain the chemical properties of the substance. The molecules are also substances capable of independent existence and still retain chemical properties of the substance. That's another definition of molecules. And we have ion. Ions are charged atom, or you can say ions are electrically charged atom, or you can say an ion is a positively charged or a negatively charged particle. So these are the 3 discrete particles of matter, and then we are going to be discussing them in detail soon. Now, of course, because the size of atom is small, it's always measured in angstrom, and then in order to be able to see some particles of atom, because we say it's small, we use what is called a scanning tunneling microscope, STM, which can magnify an image 10 million times, no matter how small it is. Okay, so that's what we use to this is a picture of scanning tunneling microscope. Okay, now let's quickly look at characteristics of particles of matter. Don't forget we are dealing with particulate nature of matter. So the particles of matter are very, very small. We are now discussing matter as a particulate, as a particle now. The particles of matter are very small. They have spaces between them. They are constantly moving, and they attract each other. Please take note. Of course, as a wave, the properties of matter has some other changes. As a wave, it has different property, but as a particle, number one, the particles are very small, they have spaces, they are constantly moving, and they attract each other. Now let's quickly look at particle models of matter. And in the particles models of matter, matter has um, three main states. Although we have more other states that have been discovered, but we have three main states. Number one is solid, number two is liquid, the other is gas, based on the physical state now. Now let's look at properties of solid. Um, Solids have a fixed shape and a fixed volume. They cannot be compressed much. They have high density. They do not fill a container completely. They do not flow. Now, before I go into more of properties of solid, during during kinetic theory of matter, we are going to talk about the state of matter in details. In a typical solid, you have the particles are joined together, they are closely packed together, and that is why it's having this property. Uh, Particles of solid are closely packed together, and they are joined. They are held together by what we call a strong cohesive force. And because they are held together by a strong cohesive force, they cannot move. They only vibrate about a main position. They only vibrate about a main position. And as such, we say they have a vibrational motion. They have a vibrational motion. Um, because of this property, they are closely packed together. They are going to have a fixed shape and a fixed volume. They are not going to be easily compressed. They will have high density. They will not fill a container easily. Um, they do not flow. Now, some of the properties of solids is density. Density is the ratio of mass per unit volume. The ratio of mass per unit volume. Example is ice cube on water. All solids have density. All solids have density. The mass per unit volume. Okay. Now let's look at another property of solid. Uh, Solids are usually they usually have shape. So one of their shape is they can form crystals. So we have crystalline solid. The individual pieces of crystal solid are called crystals. Crystalline solid is a solid whose atom, molecules, or ion are arranged in an orderly geometric three-dimensional structure. Um, uh, uh, the crystalline solids are usually arranged in this order. For instance, so when we are talking about and that's why in chemistry we look at the crystal structure of some substances. Most of the time, metals usually have this structure. Metals, sugar, salt, etc. They usually have this crystalline structure, which are well arranged. And then to study this crystalline structure, we usually use X-ray to study them. Okay, so um, I will talk more on them when we're talking about bonding. So you can have crystalline forms, they form crystals. They form crystal. An example is salt and sugar. You can see that in salt you have something like a dot, 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 like that. So they are well arranged in a three-dimensional shape. So we can have crystalline solids. We also have metallic solids, like I've said the other time. Solids can also come in form of metals. Apart from crystals, they can come in form of metals. Metals consist of positive ions surrounded by a sea of mobile electrons. Metal consists of positive ions surrounded by a sea of mobile electrons, and they usually have a metallic bond in them. They are all good conductors of heat and electricity because they have a mobile electron. They have a free ion that is moving, so they can conduct heat and electricity. Another solid that you can have is amorphous solid. Those ones, they are not arranged in any regular or repeating pattern. That means they do not have any shape. So generally, usually have a crystalline solid, and we usually or amorphous solid, as the case may be. Okay, so quickly let's talk about liquid. In liquid, for instance, the structure of liquid is such that they have spaces between their particles or their molecules, so they are still able to move in a straight line, and that is why their motion is called translational motion. And they are not the cohesive force in liquid is not as strong as solid, so you can easily break the bond and then they become a gas. So, but of course, because of the bond or the cohesive force in them, because of their arrangement, They have a fixed volume, but they do not have a fixed shape. They cannot be compressed easily. You compress them under high temperature and pressure. They have moderate to high densities. They did not usually fill container, and they generally flow. Liquids generally flow. Okay. Some of the properties of liquid: fluidity, ability to flow. You can see solid liquid flows. Please note that gases and liquids are classified under another general name called fluids. And why are they called fluids? Because they can flow. So anytime you hear the word fluid, fluid can be a gas or a liquid. Anything that flow is called a fluid. Please take note of that. But so one of the properties of liquids are the flow, that's fluidity, the viscosity. Viscosity, check your palm oil for instance. Viscosity is a measure of the resistance of a liquid to flow. You notice that they are like gum, like palm oil, they are usually thick, and the rate of their flow is low when you compare it to water. If you put palm oil and water together and pour them on the ground, you see that water flows more faster than palm oil. Why? Because palm oil is viscous, and then viscosity is a measure of the resistance of a liquid to flow. So the particles in the liquid are close enough for attractive force to be between them. Okay, so they are very close, so they have a very attractive force, so they are always resistant to flow. Liquids are viscous. An example is palm oil and gum, like I've said. Now, liquids also have what is called surface tension. Surface tension is the energy required to increase the surface area of a liquid by a given amount. Surface tension is the energy required to increase the surface area of a liquid by a given amount. So liquids also have capillary action. Capillary action is the ability of a liquid to flow in a narrow space without the assistance of or even in opposition to external forces like gravity. Ability of a liquid to flow in a narrow space. For instance, an example of a narrow space is like a test tube or a small tube where you can put a liquid. For instance, when you put a liquid through a very tiny pipe, the water will still pass. Why? Because they have a property called capillary action. They can move in narrow spaces. That's one of the properties of liquid. Okay, and of course liquid also have density, although they vary in their density, but of course they usually have constant volume, uh, um, uh, which their density varies according to their weight. The weight of the liquid determines its density, although the volume is always constant. So therefore, the greater the weight, the higher the density. The greater the weight, the higher the density. Um, you can quickly do a short experiment on that. When you have a measuring cylinder, for instance, you take olive oil, take vegetable oil, take wine, take colored water, dish soap, and maple syrup. Based on that, you are going to have the olive oil coming first, followed by the vegetable oil, followed by the wine, followed by the colored water, followed by the dish soap, followed by the maple syrup. Why? Because each of these liquid have their weight. So the greater the weight, the higher the density. So these are properties of liquids. So let's quickly talk about gas. For gas, there is negligible force of attraction or negligible cohesive force in gas. So why? Because the particles are widely apart, very far apart. So as a result of that, the gas molecules have high kinetic energy. They have very high kinetic energy, and they are able to move up and down. They are able to move on their own, on their free accord. So because of the high energy and then the free will of movement, they can collide with themselves and with the wall of their container. Therefore, gases will not have shape nor volume. they were able to they are easily compressed because of the spaces that are within them. They have very low density, they fill container, and they flow easily. That's why we say they are also fluids. Okay. Now let's look at the properties of gas. Three main properties of gas are pressure. Gases have pressure, they have volume, and then they have temperature. We call it the PVT. The PVT. They have pressure, volume, and temperature. What is pressure? Pressure is the force per unit area on the surface of an object. The force per unit area on the surface of an object. Volume is the amount of space accessible to that gas, the amount of space, and that is why you can have when you go and fill your cylinder, you can have 5 kg, 2 kg, 1 kg. Those are spaces. So volume is the space accessible to a gas, while temperature is the measure of average kinetic energy of particles in an object. So from the table here, you can see the standard unit of pressure, ATM, that's atmosphere. The standard unit of volume, liter or milliliter, as the case may be. And then the standard unit of temperature is Kelvin. We will talk more on that during the kinetic theory of gases and gas law. But to describe pressure, you just say the number of collision with the wall of the container. That's pressure. The number of collision a gas made with the wall of the container. Don't forget we say that they have high energy content, so they can collide with themselves at the wall of their container. So to describe pressure now, pressure is the number of collisions with the wall of container. Volume is the amount of space that the particles have taken up, while temperature is the average speed of the gas molecule. Okay. In differences, we can now look at differences between solid, liquid, and gas. In terms of shape, solids are definite, liquids are indefinite. That means they take the shape of their container, while gas shape is also indefinite. Volume, they have definite. All of solids have definite volume, liquids have definite volume, gas volume is indefinite. In terms of compressibility, solids are not compressible, liquids are not compressible. Although, take note, liquids are compressible at high temperature and pressure, and that's why it is possible to liquefy a gas. Please take note of that. And that is why for Israel you have a fire extinguisher. Fire extinguisher, they are liquid, they are gases that have been turned to liquid and have been compressed in a container. Okay, so liquids are compressible but under high temperature and pressure, while gas are highly compressible because they have space between them. In terms of density, um, uh, liquids are dense, gas has low density, while solid is the densest. That means that's a very, so in terms of density, solids are the densest. So solid to gas to liquid, that's the arrangement. So ability to flow in terms of fluidity now, solids cannot flow, liquid can flow, gas can also flow. That's why they are regarded as fluids. These are properties of, or the differences between solid, liquids, and gas. Let's quickly talk about phase changes before we start ending the class. Phase changes talk about the changes in the different changes in this state of matter. Solid can change to liquid, solid can change to gas, gas can change to liquid, and the like. So when solid changes to liquid, we call it melting. For instance, take a ice cube, put it in a pot, light fire, and then you see the ice melt to become liquid. So liquid also can also change to solid. Take a water, put it inside a freezer, it becomes block and it becomes solid again. So that we call it freezing. The temperature at which a solid changes to liquid is called the melting point. The temperature at which solid changes to liquid is called the melting point, while the temperature at which liquid changes to solid is called the freezing point. Okay. Now liquid can also change to gas. By when you heat up a liquid, it forms a vapor, and we said, and you could see the vapor evaporating, escaping. So that process by which liquid change to gas is called evaporation. And then when you take a chilled coke and you bring it out, you notice that after some time you see water beside the bottle of the coke. What has happened is that the gas that is coming out has been changed to liquid. We call that one condensation. We call it condensation. Please take note that the temperature at which a liquid change to gas or a liquid boil or change to steam is called boiling point. When it involves changing to vapor, we can call it vaporization. When a liquid changes to vapor, we can call it vaporization. Please take note of these key terms. And then of course, when a solid changes to gas, we call it sublimation. A typical example is when you put camphor inside. Camphor is solid, okay. When you put it inside your clothes, after 3 days you won't find it again. The camphor from solid has changed to gas. So we say the camphor are sublime. Then there are some substances like naphthalene, like iodine crystals, like ammonium chloride. When you heat them up, they change to gas immediately. So that is called sublimation. And then of course, a gas can also change to solid. This usually occur in areas like Antarctica. That's the seventh continent, where you have solid ice where you have ice or gaseous substances changing to solid ice. So that time where gas change to solid is called deposition. It's more common with a continent called Antarctica, the seventh continent of the world. Okay, these are activities that you can do. Make sure you complete this activity for solid, liquid, and gas. Please, I've mentioned something on them. Complete the diagram as well. Complete this diagram, and then of course answer the following questions. In your work there. Okay. Let's quickly talk about changes that matter undergo. Matter can undergo two changes: the physical and the chemical change. Matter undergoes two changes: physical and chemical change. What is a physical change? A physical change occurs when a substance changes but no new substance is formed. A physical change occurs when a substance changes but no new substance is formed. Um, uh, for a physical change, we can have change in size, in shape or form. You can have change in state of matter. You can have, of course, you know that physical change is reversible. Physical change is reversible. Okay, so for chemical change, a chemical change occurs when a new substance is formed. A chemical change occurs when a new substance is formed. In physical change, for if you want to have example, for instance, the melting, for instance, melting. If you melt a ice, for instance, and it turn to water, you can make the water become ice again by freezing it inside your freezer. That is a physical change. Why? Because no new substance is formed. Water is just changing form, and of course changing sizes and the like. So no new substance is formed, and of course it can be reversed. You can make water to form ice. You can make ice to form water. It can be reversed. In fact, if you want to measure for you to know that no new substance is formed, there is no change in mass, because you can measure the ice using your scale, and then when after it become water, measure it again, you have the same mass, as the case may be. So and there is no change in mass. So that's a physical change, easily reversible. No new substance is formed. All you have is change in size, shape or form, and or change in state of matter. For chemical change, new substance is formed because there can be a change in color, a gas can be given up, a new solid can be formed, there can be a change in temperature. All chemical reactions they are chemical changes. For instance, and a typical example in terms of color change now can be rusting of iron. Rusting of iron. For instance, when you get iron, a nail, for instance, and then when the nail is coming in fresh, like a silvery white color, like this, then after some time you notice that the nail has become brown. What has happened? There is a chemical change. The iron has changes from iron 2 to iron 3, from the color it has to a reddish brown color. That's a chemical change. So color could have change. When you have a solid, when you dissolve a solid or a liquid inside a liquid, you could have a precipitate being formed. That is another chemical change. Then you could have, when you put a metal like a sodium metal and you add an acid to it, you could have bubbles. We call it effervescence. Bubbles of gas can be formed. That's a chemical change. That's a chemical change. Gamma gas is being formed there. It could produce heat or light, as the case may be. So those are chemical changes. And of course, know that chemical change is hard to reverse. For instance, when you boil or fry egg, when you fry egg, you agree with me that it becomes another thing entirely. You cannot take it back to become the original egg. The only thing you can do is to eat it. That's on a lighter note. So when egg is fried, you cannot change it back. So it's a chemical change. It is irreversible. Okay, quickly let's look at different differences between physical and chemical change. Number one, a physical change is temporary, a chemical change is permanent. In a physical change, no new substances is formed. In chemical change, new substances are formed. In physical change, no change in mass. In chemical change, there is a change in mass. In physical change, no energy or small energy is involved. Um, in chemical change, energy is generally involved during the change. Then we have examples. Examples of physical change are melting of ice, lighting of bulb. You can decide to off the bulb. So it's also a physical change. Dissolution of salt is also a physical change. When you dissolve salt, you can recover that salt back by evaporating, heating the salt. You get the salt back. For chemical change, chemical reactions, burning of fuel, combustion of paper. You cannot burn paper now and get the paper back. It has gone forever. So all combustion reaction, explosions are all chemical changes. So far we have learned a lot in our introduction to particulate nature of matter. We have looked at properties of matter as a particle. We have looked at discrete particles of matter. We have looked at properties of matter. It's the physical and chemical property. We have looked at state of matter. There are changes in matter. We have looked at change of states when it comes to solid changing to gas, and we look at state of matter and their changes. We have looked at some of the theories postulated by Democritus and Dalton. We have looked at discrete particles of matter, atoms, ions, and molecule. These are some of the topics that we have looked subtopics we have looked at. We have established that matter has space and occupy and has mass and occupies space. We have looked and we have defined what a mass is and what a volume is. So in our new topic, we are going to look at how matter came to being, and much more specifically atomic structures of matter and other ones. We look at elements in detail, compounds, mixtures in details, how these mixtures can be separated, because we have said that matter is composed, we can generally classify matter as pure substance, which are subdivided into um, compounds and elements, and then we have mixtures. So we will need to study mixtures. We also study elements. How are elements classified? What type of element do we have? What type of compounds do we have? Then what type of mixtures do we have? And then how can we separate these mixtures? Since we know that mixtures can be separated by physical method because they are physically joined together. How do we separate them? And all other ones like that. So I hope you have learned and enjoyed this lesson. Do well to keep up with the new lessons as we continue to further dig down into our study of matter. Don't forget that we have said that everything about chemistry involves the study of matter. Continue to learn chemistry, and make sure all the exercises practice them. Also make sure that you state more examples. An assignment I will give you is give more examples of physical change rather, like 5 more, and more examples of chemical change like 5 more as well. Continue to learn chemistry, and bye bye.